Oh, they have to like stand.
Yeah, you're fine. No, it just kind of pans wide. No, you're fine. Yeah. Okay.
So my name is Albert Zan, and I'm a senior this year. This is my second internship, and it is at Biamp Systems. I'm not sure if you're familiar, but they're in Beaverton/Tigard, so right on the border, and they manufacture audio equipment for commercial applications. So you probably heard of them, I guess, in the sense that airports, churches, auditoriums at schools, anything where there's a big gathering of people, even Broadway shows, stuff like that.
So what's your major?
Oh yeah, I'm a software engineer major. One of the few. Okay, so company history. This is actually a very old company, but it went, I guess, modernized at one point. Bye. Oh, I'll let you sit down. Okay, so if you're probably familiar with mixers and the whole audio equipment, right? Big boards with a lot of knobs and sliders. DJs use them. We kind of make the same thing, but more in a modernized sense. Everything is digital. So a lot of DSP, digital signal processing, everything's controlled in software, and you just get one box where you plug microphones, speakers, amplifiers into, and it does all the work for you. So it's not as cool as like having a mixer board where you play with the knobs and stuff, but it does the same amount of work. So originally, the company was actually catering towards musicians, so personal use. But in the 1980s, they moved towards permanent installations. So gyms, auditoriums, airports, stuff I mentioned earlier, and it became commercialized. And as of right now, Biamp only caters towards commercial uses. So you can't go into your local music store and buy, I guess, an amplifier from them. Okay, so the work hours is 40-hour week, pretty standard. As an intern, it's by hourly, but as a full-time, you're salaried. So it's still pretty flexible, unlike my previous intern work at Intel, where they promote work and life integration. So you're given a laptop, you're expected to go home and do work. Here it's work and then home. Clear separation, they don't force you to go home and do any work. Flexible work hours, you can show up whenever you want and leave whenever you want. The only thing is that you should be consistent. I guess that's what they teach you. So don't show up 8 and then 10 the next day and 12 the next day. Keep a consistent schedule and then you're good. Yeah. So I was part of my own team of one. I guess at a smaller company, everyone is expected to be more independent and you get your own, I guess, autonomy. You get to make your own decisions. As long as you did your work, you're not going to get fired. And yeah, so I work by myself for the majority of the time. There is a different management style than what most companies have nowadays, and it is a matrix management. So instead of having a direct manager, you have I believe it's called program manager. So you're responsible for this product, but you also report to a technology manager. So there's technology and program managers. So you have two managers. And so you're kind of like a shared resource. Sometimes the managers just drag you around, hey, work on this. Sometimes you get your own product, but it's still teams of one, unless the feature is really big, and then teams of two, I guess. Super rare. So here are the boxes that we make, I mentioned earlier. A lot of digital signal processing. It's pretty simple by the looks of it. The back is where all the I/O ports are, where you can plug microphone amplifiers, stuff like that, Ethernet cables into. The front, you just get a little display panel where you get to see the status, and everything is controlled through software. So here are the basic SKUs that they have: Tesera Forte, server I/O, and expanders. So the first three are the actual brains of the system. So they do a lot of processing. So if you have a mic that's really low in terms of volume, it would be able to amp it up. So the last one, expanders, it adds I/O configurations to the server devices. So the first three. Whoops. Okay. I didn't even swipe. So expanders kind of plug into, okay, so see, these ones are expanders. They plug into one of these and it gives you extra I/O ports. So maybe you have like 20 microphones and you don't have enough, just add expanders to it. And my project is the scalability project. So each one of those boxes can interoperate with every other box. So if you have like a stadium, a football stadium, you have a lot of little rooms, but you want everything to be tied together. So if there's like an emergency, you want the PA to be able to announce to every single room. But everything is also segregated. So maybe you have a meeting in this small room while a main event is going on into a big room. So since everything is hooked up together, my project is to test how big it can get. So things like network latency, I guess firmware. When you start scaling really big, it gets really slow or crashes. Well, theoretically, but we don't know that because each device takes up a certain amount of floor space. And some clients are approaching 100, 200 devices. And that's a lot of floor space to a lot of inventory to pull out and have on hand to test to see if it really works or not. So my project is to test how big it can scale without breaking, but in a virtual sense. So instead of having physical units, everything is simulated on a server. Okay, so under the hood, that's what the picture on the right is what it looks like, the server class devices, so not expanders. You can see there's right here, the white slots, those are expansion slots. In one of the previous pictures, when you order a device, it comes as a bare bones unit. So say you have no need for microphones. You can order a device that has no microphone support. And then when you need microphones, you can buy an expansion card and stick it into the slot. And then you have microphone support. So all those cards add different functionality to the main server. When you buy the main server, it does some limited, I guess, functionality. But since it's scaled this way, you can actually have a super cheap unit, in the commercial sense, cheap unit without having unneeded functionality. Okay, so this is an embedded product. So there's an executable running on PowerPC processor on the board. It can also be compiled to run on Intel, so one of the desktop computers. So my project was to recompile that executable onto a desktop, so it can be ran on a desktop computer, and then figure out a way to scale it. So make different virtual environments so that we can run it. So it's to simulate, I guess, multiple boxes. Going back. Okay, so problem statement. I needed to create a framework that allows engineers to create and delete virtual machines. So here we're using VirtualBox to house each executable in its own environment. And VirtualBox is kind of like a computer in a sense. It runs its own operating system. It has it's pretty much a computer minus the physical. So one computer, you can house multiple VirtualBox instances, and each being its own operating system. I need to be able to update the executables running inside those VirtualBox instances and allow the engineer to perform bulk operations. So say an engineer can come in and say, hey, I need 200 boxes. Can you create that for me? So they need a central interface where you can go in, specify 200 units, and then specify what kind of device it is, whether it's to serve a server, Forte, or expanders. So what I learned through this internship, design. A lot of people don't like writing pseudocode for those in CSAT, and that's when you draft code not in a specific language in a general sense, so you can get algorithms and stuff like that down. But it's very important when you start scaling up. You start to run into problems where it works in a smaller scale, but as soon as you start going up, there's different boundary issues. So say you have one computer that's running a simulation, and you add a second computer in. Now all of a sudden you have network latency issues between the different servers. You have storage issues. Should you store virtual machines on computer A or computer B? And if you go into a project programming right away, yes, you get a product out really fast, but when requirements change, you have to change your code. Whereas if you pseudocode first, you can change your pseudocode and it's a lot faster. You don't waste as much time. I also learned about the Linux culture, which is we are primarily Windows-based in the CSAT department here. So going into a Linux-based system, it's a little different. I had prior experience, and it was definitely a lot to learn. It's definitely different. The Linux culture prioritizes developers. So whereas in Windows, you have fancy user interfaces where you can use a mouse. In Linux, the programs are written in the console. So they only write text to the console, and input, you have to type on the keyboard, put text into the program. And that allows you to bridge different programs together, like pipe the output of one program to the next and chain programs together. Every program in the Linux environment does one thing and one thing only, whereas Windows is kind of like a conglomerate. Let's see, time spent debugging, which is versus time spent designing. So here, going back to pseudocode and doing a good design process before you start programming things, it really helps in the big picture, in the long run. And it's good to get a big picture sense of what you're programming. And what makes someone a rock star programmer isn't how well you write code, it's how well you understand your problem. And if you can draw a big picture and understand the different components that goes into it, you can program pretty fast. But when you have to stop and think about how each piece interoperates and hooks up together, that's when you start hitting snags. And you're not programming, I guess, using the most out of your time. Scale out and not up. So my project, like I said earlier, was a scalability project. I had to simulate virtual machines on a server. And at one point, so we bought a server specifically for this task. And it was some Blade server. It sits in a closet, you never get to see it. And it was like $2,000 computer or something crazy like that. And originally, we wanted to run 128 instances, VirtualBox instances, so we can have 128 devices running. However, through testing, we couldn't approach that limit. So one of the, I guess, philosophies is scaling up, which means that you buy more hardware for it, more RAM, more hard drive space, a faster CPU. And that gets really expensive really fast. But we also have a lot of old computers lying around, old desktops like that, old laptops that we can use. And that is called scaling out. You have a lot of crappy computers that you can power on, and your floor space gets further outward, widened, instead of going up. So it's really cheap, and that's the route that I ended up going. I ended up writing an orchestration layer, basically a single program where the developer would go in and say, hey, I want 200 machines. And the program would look at the various servers that's attached to it and say, oh, this one is free, this one's also free. Let's schedule 100 here, 50 here, and then the remaining on the third machine. So in a sense, scaling out, you can maximize your money in terms of, maximize your money, and I guess time as well. You don't have to spend time purchasing and waiting for equipment to arrive. We have a lot of old machines lying around. And then the last one is a quote. A foolish consistency is the hobgoblin of little minds. So what that's basically saying is that do not stick to being consistent. Don't follow all the programming rules, syntax rules. Well, syntax you have to, but commenting rules, comment blocks, and stuff like that. You want to follow it, but not strictly. At the end, shipping a product is important, and I have this problem where as a craftsman, you kind of see, oh, this can be improved. Oh, this can be improved. but you never actually get to shipping the product. And that is very important in terms of software design. And at the end of the day, everything has to ship to make money. So I improve in that regard as a software engineer through this internship. So the final product, let's see, it's basically a command line application. So there is a graphical user interface, but through the command line window. And you can only interact with it through the keyboard. There is no mouse support. You cannot see that, but that is what it looks like. So you can browse through different menus, select different functionality, and yeah, can't see it, it's black. Okay, and courses that help me. I guess, yeah, like professors going into college here, they always say, learn how to learn. And that is a very true statement. When you come out of college, you think you know everything, but stepping into your first job, it's very different. You know pretty much nothing. And this internship proved that to me. But what I did take away from school here is learning how to learn. So approaching things methodically, seeing what you know, use that as a basis for developing new skill sets, new tools. And that really sets you up to be successful. Okay, I want to do that. So this is my second internship. The first one is through Intel, and here's some differences. Intel being a massive global company, and IAM's only in 3 locations, in Beaverton, Brisbane, and somewhere in New York, I believe. So in a bigger company, there's a lot of different levels of management. To do any single task, there's a specialized department for it, which kind of gets in the way. So a lot of red tape. Whereas in a smaller company, you have a lot of autonomy. You can just do whatever you want. So I kind of like that. Intel promotes work and home life integration, whereas IAM, as a smaller company, it promotes leaving things at work and having a separate home life. Let's see, casual dress code at Intel. I have to dress up at IAM, even though I have a hoodie on. And yep, that's it. Questions?
So where are you working now?
Huh?
Where are you working now? Did you get a job? Did you keep the job at IAM or?
Actually, well, so right now they don't have an open position, but they are interviewing me for an upcoming open position. So take it with a grain of salt. I don't know what that means, but yeah. So I'm actually looking for jobs on the market right now. And typically, I think MECOP students after the second internship have 6 months. Is it 1 year of school left? I think it's 1 year, right?
Usually, yeah, 6 months. Yeah,
6 months.
usually, yeah.
Okay.
Usually they come back. For CSET, they have 6 months left.
Gotcha. So yeah, throughout the summer and fall internships, I actually took classes online. And if you want to graduate early, that's actually pretty good. They don't expect that much out of you in terms of like after work life. So if you're dedicated and really want to finish early, you can definitely do that. So after I finish my second internship here, I'll be completely done with school, hopefully. Any other questions?
Or you do want to go back to work at IAM?
Yes. They are very, are you software? Mechanical, okay. They are very strict in terms of how they do things. There's a procedure for everything, and I don't want to say anal, but yeah, they're very specific, and it matches very well with my personality. I like things being done correctly. So yeah, in terms of potential growth, it's definitely there. Everyone is very experienced. We have an employer that worked with Steve Jobs, and when Apple was first starting up, like he's in his 70s, I don't know why he's still working, but super smart. And the average engineering age in the company is like, well, average engineer's age is like 50. Everyone's very seasoned, so it's very hard to fit in at times in terms of
looking for new engineers the next 10 years.
Yes, exactly. yeah, it's hard to fit in, but in terms of learning, you definitely can pick their brains.
Mhm. Interesting.
I'm surprised you don't have a user interface, that looks pretty,
Yeah, it's targeted towards developers, so only engineers would use it, internal to the company.
I see.
Yes. Yeah, I'm not a user interface person, so I'm kind of glad they didn't require me to make something that's pretty.
You can have a bunch of dialog boxes. Everybody
Yes.
loves dialog boxes.
That's exactly what I made. Anyone else? No?
Ooh, all right. Thank you. Thank you, Albert. All right.